Non-renewable sources of energy. This is also called alternate sources of energy. If we talk about it, then let's see in contrast with the conventional sources of energy. In conventional sources of energy, the energy is present in limited quantity. That is, once they are exhausted, they cannot be renewed because they come under the category of non-renewable sources. But these non-conventional sources of energy comes under the category of renewable sources. That is, they are present in unlimited quantity. Once they are exhausted, then they can be easily renewed. Now let's see that what are the example of these sources. The first example of this source is hydro energy. Then the wind energy, the solar energy, the biomass energy, the geothermal energy. Now let's first start with the hydro energy. The word hydro means water. My God, water. This water generally is used to produce electricity. The electricity which is produced from water is called hydroelectricity. This hydroelectricity which I am talking about is not like that we convert the water into the electricity just like that. No. There are proper power plants or the power stations installed in order to convert the water into the electricity. The water which I am talking about is the water which falls from a particular height. That is the free falling water. When this water falls from a particular height, then it possesses high amount of kinetic energy. This kinetic energy is converted into electricity by using hydropower stations, and the electricity generated in this process is called hydroelectricity. Now let's start with hydropower stations. These hydropower stations are also called hydroelectric power stations. Why it is known as hydroelectric power stations? Because it is used to convert hydro, that is water, into the electricity. So when we combine it, it will become hydroelectricity. Now let's see the principle behind it. In this principle, they use the free falling water. When the water falls from a particular height, then it is under high pressure, and this high pressure water is made to fall on the rotating blade which is known as turbine. So when this free falling water falls on the turbine, then the turbine is made to rotate and the turbine is connected to the generator. When the turbine rotates, the generator gets driven by it and is used to produce electricity, which is used to supply the electricity to the locality, home, industry and so on. Now let's start with the constructional detail. In this diagram, you can see that there is a hydropower station. This hydropower stations consist of various sections. Now let's discuss it one by one. First, we will start with the free falling water. When the water falls from a particular height, then it is stopped or obstructed by the dam. What are these dams? A dam, we can say, is a barrier or an obstruction to the flow of water. When this dam is constructed, then the flow of water is stopped or hindered by it. It is basically a high construction which is used to stop the flow of water. Now, behind the dam, when the water gets stopped, then the water starts accumulating, and the place where the water starts accumulating is called reservoir. So what is this reservoir? Reservoir is basically a natural or the artificial lake in which the water content is there, and it is used to supply water. So behind the dam, the reservoir is created. Now you can see from the diagram that the dam consists of one outlet. This outlet is controlled by the gate provided at the outlet. This gate is also called sluice gate or the sliding gate. This gate, when remains closed, then no water flows out, and when this gate is open, then the water flows out from that outlet, and that outlet is also called intake. When the water flows out, it flows through the penstock. This penstock is basically a channel or a pipe through which water flows out. It is generally used to give direction to the water. Now, the water from the dam outlet flows out through the penstock, and this water which flows out from the penstock is generally from a great height. So, it possesses high amount of kinetic energy. Due to this high amount of kinetic energy, the pressure in the water is also very large. And this high pressure of water, when it is made to fall on the rotating blade, which is called turbine, then the turbine starts rotating with it. The turbine rotates due to the high pressure of water. Through the turbine, the shaft is attached. The shaft is basically a long rod or the connecting instrument. This instrument is used to connect the turbine to the generator. When turbine rotates, the shaft also rotates. And due to the rotation of shaft, the other end of shaft, the generator is connected. When the shaft is rotated, it drives the generator. As soon as it drives the generator converts the rotational energy into the electrical energy. How this rotational energy is created? The rotational energy is created by the high pressure of the water. So when the electricity is generated, it is used to transfer it to the further electric power stations. So this is how the hydroelectric energy is utilized. As soon as the water starts converting into electricity, the level in the reservoir gets decreased. But it again gets refilled by the rain or the river flowing. So that's why it is also called the renewable source of energy, because the water is inexhaustible. Now the second form of energy is the wind energy. Yes, the wind. This strong moving air basically constitutes wind. Now, the energy which is made from the wind is called the wind energy. This wind energy is converted to make electricity. In order to generate electricity, we use windmills. Now, the windmills are constructed in order to convert the wind which is flowing, that is moving air, into the electricity to run the power stations. Now, let's first start with the windmill. The wind is the renewable source of energy because it cannot be exhausted. The wind is produced basically by the solar action that is caused by the unequal heating of the earth. Now, if we talk about the windmill consists of like a large table fan. You have seen a table fan. The table fan consists of large blades. So, the windmill also has long blades. These long blades are installed over the pole. Now, this structure is your windmill. The pole acts as a supporter for the blade to rotate, and the blade which is rotating is called the wind turbine. Now, the wind which flows, this possesses high amount of kinetic energy. This kinetic energy, when it falls on the blade, then it causes the turbine or the blade to rotate. When the blade starts rotating and it acquires sufficient speed, then the shaft is attached to the turbine. This shaft also starts rotating with that of the turbine. The shaft is connected on the other hand to the generator. When the shaft starts rotating and it gains sufficient amount of speed, then it drives the generator. The generator is used to convert the rotational energy into the electrical energy. This electrical energy is used to run the electric power stations. In this way, the wind energy is converted into the electrical energy. Basically, one windmill generates only small amount of electricity. But if high amount of electricity is required, then you need to install large number of windmills. And the area where large number of windmills are installed, that area is called wind farm area. So, this wind farm area requires larger area to install. And in that condition, we have to look for the particular area. Second, the windmill is installed in the location where the heavy wind is flowing. It cannot be installed just like that in any of the location. But we have to search for the particular area where the wind moves in a faster rate. The third important point is that the flow of wind must be steady and uniform. If the flow of wind is uniform, in that condition only the turbine acquires the sufficient speed and the maximum amount of electricity is generated.